Curiosity gets cozy, and cosmic questions are tucked gently beneath a pillow. Tonight's slow unravelling takes us beyond the veil of city lights and moonlit clouds, far past the weathered orbit of our little blue planet, into a question both ancient and astonishing. Just how powerful is humanity? Not powerful in the sense of politics or pride, but in energy, in reach, in scale. How much of the universe could we possibly command if we had the time and the tools and the dream? There's a way to imagine it. A ladder of civilizations, each rung rising toward the stars. It's called the Kardashev Scale, a cosmic scoreboard, drawn not in medals or monuments, but in megawatts. It's one of those ideas that makes you feel very small and wildly important all at once. So before we begin our sleepy ascent, I'd love to know, where in the world are you right now? And if you glanced at a light switch just now, how much of the universe do you think that little click represents? If you find comfort in drifting through these kinds of wonders, if this voice and these questions feel like a good companion to your end-of-day quiet, I'd be ever so grateful if you'd give the video a like, maybe even subscribe. It helps this soft space grow, gently, in all directions. But now, dim the noise, let the day release its hold, and let's begin. Because somewhere between campfires and quasars, battery packs and black holes lies the question of power, and how far it might carry us through the dark. Power. It's such a sharp word, isn't it? In most of our lives, power doesn't arrive as a lightning bolt. It hums softly, in the glow of a bedroom lamp, the buzz of a refrigerator, the soft whirl of a laptop late at night. It's in the charge of a phone that cradles our calendars, our conversations, our memories. Invisible, instant, assumed. We don't often stop to think about how remarkable that is. That the flick of a switch summons light from a wall, that a tiny rectangle in your hand can call another tiny rectangle on the other side of the earth. That when we heat soup or light candles or open a door with a motorized hiss, we're bending the universe ever so slightly to our will. But power, real power, hides in plain sight. It's in the comfort of hot water in the morning, in the way cities stay aglow while stars vanish, in the confidence that your toast will pop up golden instead of blackened smoke. We rarely call it energy in those moments. We just call it working. And yet, if you pause, if you look around your room right now, almost everything you see is quietly spinning because of fire made invisible. Electrical grids, fossil fuels, solar panels sipping photons from the past. Human civilization is draped in a shawl of stolen starlight, woven from 100 centuries of learning how to burn, capture, store and control. But how does that feel? Oddly, normal. We live inside a miracle so constant we call it mundane, a world where people get annoyed when the Wi-Fi hiccups, where waiting 40 seconds for the microwave is cause for complaint, where we carry in our pockets more computing power than what guided astronauts to the moon. So what does power feel like? Sometimes it feels like impatience. Sometimes it feels like forgetting how amazing everything is. And sometimes, like now, it feels like wondering what lies beyond our current reach. Wondering, are we powerful yet? And if not, what would it take to become so? The truth is, we only really notice power when it's missing. In a blackout, the room swallows itself. The fridge sighs into silence. The digital clock becomes a blank stare. And you're left, suddenly, with the ghost of all your machines, powerless but present. That's when we realize how much of our comfort, our rhythm, our sense of modernity is floating on a current. Electricity is a language we don't even speak. We just live in it. But zoom out just a little further, and the story deepens. What if, instead of a single person in a dark room, you were an entire species in the dark, flicking switches, building things, warming homes, launching satellites? And you asked, how far can we take this? That's where imagination begins to stretch, And it turns out this is not a new desire. Power, as an idea, has always been with us. Not just the power of muscles or money, but of tools, of control, of bending nature to need. Early humans tamed fire, later water, then wind, then coal, then atoms. And always with one eye looking upward, to the stars. Because there's a feeling somewhere deep inside us, one we don't speak of often, but you've likely felt it, that perhaps we are meant for more, not in a grand, prideful way, but in a whisper, a question. Are we still small, or are we already becoming something more? Now pause here for a moment. Try to remember a time you stood outside at night, far from cities, far from phones, and looked up. The sky above like a velvet canvas pricked with cold diamonds. Maybe you felt small, maybe you felt ancient, or maybe you felt powerful. Not because you could reach those stars, but because you wanted to. That desire to reach, to build, to expand, to harness, is one of the most ancient feelings we carry. We dream of more, and that dream has weight. The Russian astrophysicist Nikolai Kardashev once tried to measure that dream. Not the ambition itself, but the potential behind it. What if, he wondered, we ranked civilizations not by their culture or their art or their philosophy, but by the energy they could control? That idea, the Kardashev Scale, is what brings us here tonight. But before we climb its steps, it's worth lingering in the hallway for a while, because the very notion of scaling civilization by energy, of linking power to progress, feels strange, exciting, yes, but also a little cold, a little clinical. After all, we're taught to value kindness over kilowatts, empathy over entropy. And yet, in the quiet corners of thought we sense the truth. Energy is possibility. It's the difference between surviving and thriving, between a candle and a continent, between dreaming of the stars and reaching for them. When a child draws a rocket ship, they are sketching the future of fuel. When someone turns on their heat in winter, they're performing a kind of soft magic, the world yielding just enough to make a room feel safe. But how much energy do we truly control? Not in a household, not in a city, but as a species? The answer is humbling. By Kardashev's reckoning, we haven't even reached Type 1. That's the first rung on his Imagine ladder, a civilization that can capture and use all the energy available on its home planet. Every gust of wind, every wave, every photon of sunlight, every drop of geothermal fire, every possible output Earth could offer, harnessed with ease. Humanity? We're not there yet. We're somewhere around 0.73, not even a full step, but we're climbing. And here's where perception begins to play tricks on us again, because in daily life, surrounded by screens and sound and signal, it feels like we're already mighty. A global internet, skyscrapers taller than clouds, machines that diagnose disease, simulate worlds, translate languages in real time. We make metal fly. We teach circuits to think. We beam live concerts to opposite hemispheres. Surely that counts as power. It does. But Kardashev Scale asks a different question. Not what can you do, but how much energy could you command if you needed to? It's a haunting question, and a hopeful one, because beneath it lies something deeper, potential. We are still growing, still stumbling upward, still in Kardashev's eyes a species at the start of its story, and there's comfort in that. Because every light that glows around you right now, every whisper of electricity in the walls, is part of that slow, quiet climb. Every invention, every idea, every time a scientist connects a circuit or a child wonders where electricity comes from, we move a fraction higher. Power, it turns out, is not just about what we can do. It's about how we dream when no one's watching. And in the dim light of a sleeping Earth, some part of us is always dreaming of stars, long before wires pulsed with current or satellites blinked awake in orbit. long before switches, sockets, and streaming services became part of our bedtime routines. Humanity was already dreaming about power. Not the kind measured in kilowatt hours, but the kind whispered in stories carved into stone, burned into the sky by lightning, and into memory by wonder. You see, before we understood energy, we worshipped it. To the earliest people, the most obvious source of power was also the most untouchable: the sun. The ancient Egyptians called him Ra, a god with a falcon's head and a crown of fire. He sailed across the sky in a golden boat, illuminating the world by day and descending into darkness by night. His journey gave rhythm to life: daybreak, dusk, death, rebirth. To them, this sun was energy incarnate, not just warmth and light, but order and time itself. Without him, the world unraveled. In Mesoamerica, the Aztecs told of Tonatiuh, the fifth sun in a cosmic cycle. The previous four had each died in fire, flood, jaguars, or wind. To keep the current sun alive, they offered blood, their own energy, in return for cosmic continuity. In ancient Vedic texts from India, Agni was the fire god, the mediator between humans and the divine. He carried messages through flame. Every ritual, every candle flickering in the wind was a conversation with the cosmos. To the Norse, it was Thor's hammer that split the sky with lightning, a divine burst of raw electric fury. To touch it would be death. To wield it was godhood. And across so many traditions, Greek, Babylonian, Chinese, the elements held power: fire, wind, earth, water, not tools, not resources, beings, spirits, forces of their own will. Power wasn't owned, it was borrowed, and only briefly. Even Prometheus in myth didn't create fire. He stole it from the gods. And for that defiance, for giving humanity its first spark, he was chained to a rock, punished for all eternity. It's a strange echo, isn't it? That even in our earliest stories, power comes at a cost. But for all the reverence and caution, there was always awe, a deep, primal awe. Fire crackling in a dark cave, a thunderstorm unravelling above a village, the hiss of steam from a pot over coals. These weren't utilities, they were visitations. To see power was to feel the breath of something beyond comprehension. And yet, humans are endlessly curious. We watch, we wonder, and eventually we imitate. The first sparks of technological energy came not from divine gifts, but from observation. Wind turned leaves, then it turned sails, then mills, water-carved valleys, then it spun wheels, then turbines, fire-cooked food, then forged tools, then turned engines. Each step was a shift, not just in ability but in perception. We stopped asking, what god made this happen? And started asking, how can we make it happen again? That shift didn't happen all at once, it took thousands of years, and it's still happening even now. In ancient China, engineers built intricate clocks powered by falling water. In Baghdad, inventors crafted devices with steam and pressure. The Greek engineer Hero of Alexandria designed a primitive steam turbine, a curiosity, a toy, but also a prophecy. By the Middle Ages, cathedrals soared skyward, not just to honour gods, but to showcase human reach. These buildings weren't just spiritual centres, they were engines of awe, powered by manpower, mathematics, and an increasingly ambitious view of what humans could do. But true transformation came with the Industrial Revolution. Suddenly, power was no longer symbolic. It was measurable, purchasable, scalable. Coal-black furnaces breathed heat into cities. Steam engines pulsed across continents. The first power stations flickered to life. And for the first time in history, night could be postponed. Electricity became more than a curiosity. It became infrastructure, a quiet promise that the dark would never quite win again. But even as machines multiplied and empires industrialized, cultural memory clung to older ideas. Power still felt sacred, dangerous, seductive. Mary Shelley's Frankenstein, often called the first science fiction novel, was less about monsters than about ambition. Electricity reanimates the dead. But what happens when we try to harness forces beyond our wisdom? That same tension echoes today. In every conversation about artificial intelligence, nuclear energy, genetic editing, the question is rarely just can we? It's always, quietly, should we? And so, power, as both a concept and a reality, has always worn two faces. It brings light and risk, freedom and fear, hope and humility. But if we step away from inventions, away from wires and oil rigs and solar panels, and look again at how cultures have felt power, the picture softens. Many indigenous traditions don't see energy as a thing to dominate, but as something to live within. Among the Maori of New Zealand, there's a concept called Mori, the life force in all things. A rock has Mori, so does a tree, so does a person. It's not about consumption, it's about connection. In Japanese Shinto, there's kami, spirits that inhabit nature, objects, moments. A waterfall can be kami, so can the wind. These aren't resources, they're relatives. Even today, in modern language, echoes of these ancient feelings remain. We say someone has good energy. We talk about feeling charged or burned out. We describe people as radiant, magnetic, full of spark. We talk about motivation like fuel, love like warmth, anger like fire, calm like still water. Energy, in all its forms, is still how we describe the invisible movements of our lives. And now, in this moment, with satellites in orbit and electric cars on roads, we find ourselves between worlds. We live in a time where energy is both sacred and boring, where a solar flare from the sun can dazzle scientists, and a phone battery dipping to 12% can send someone into panic. We've become masters of miniature miracles, but still, the big dream remains. The dream of more reach, more possibility, more connection, more light. And so the Kardashev Scale arrives not just as a science fiction curiosity, but as a kind of mirror. It reflects what we've always done, climb, from myth to machine, from fire pits to fusion labs, from sun gods to solar farms. We have always sought to capture what once felt untouchable, not out of greed, not always, but often out of longing to survive, longing to thrive, longing to see what's just beyond the next horizon. Every culture, every era, every village with a flame, every city with a skyline, every child pointing up at the stars. It's all been part of the same story. A story not of dominion, but of becoming. Becoming something slightly more capable, slightly more aware, slightly more able to shape the universe without breaking it. And that is where history and culture intertwine with science. Because long before anyone said type 1 or type 2, long before Dyson spheres and megastructures and energy equations, humanity already knew what it felt like to touch power. Carefully, briefly, reverently. We still do. Every time you plug something in, every time you see headlights in fog, every time your body warms in the sun, that's not just convenience, that's contact. And perhaps the great civilizations, the ones higher up the Kardashev scale, don't just have more energy. Maybe they've learned how to feel it too, to notice it, to honor it, to hold it with both hands, and then let it go. Because real power may not be in what we command, but in what we remember, even after we do. To understand the Kardashev scale, not just its tiers but its tone, we need to shift how we think about growth. Not the kind you can see in a mirror, not even the kind marked on graphs or charts, but a stranger kind. A growth in what we can influence, and how far that influence can reach. Nikolai Kardashev proposed his famous scale in 1964. He was an astrophysicist, tuned not only to the mathematics of the cosmos, but to the possibility of what might live within it. He asked, quietly but profoundly, if intelligent life exists elsewhere, what would it look like? And more importantly, how would we recognize it? In a universe where signals drift across billions of light years, filled with noise, dust, and time, how could we ever spot another civilization? His answer was simple, elegant, not about language or culture, but about power. Look for energy. More specifically, look for the footprint of energy use. A truly advanced civilization, he argued, wouldn't need to announce itself. Its existence would be betrayed by its hunger. Planets wrapped in collectors, stars dimmed by absorption, galaxies whispering in infrared, not because they're shy, but because someone out there is using the light. This was the birth of the Kardashev Scale, a framework for measuring technological advancement based not on morals or machines, but on how much energy a civilization can harness. He divided it into 3 core types. Type 1, a planetary civilization, one that captures all the energy available on its home planet. Every ray of sunlight, every gust of wind, every geothermal shimmer beneath the crust. It can manage weather, prevent earthquakes, perhaps even redirect hurricanes. This is mastery of a world. Type 2, a stellar civilization, one that captures the full energy output of its star. Not a little, not some, but all of it. This might involve constructing a Dyson sphere, a hypothetical megastructure that surrounds a star and collects its light, an entire sun wrapped in engineering. This is not science fiction. It is science with bold imagination. Type 3, a galactic civilization, one that spans an entire galaxy, harvesting the power of billions of stars. It can rearrange solar systems, navigate black holes, perhaps even rewrite the laws of physics at will. This is not just civilization, it's orchestration. So where are we? We, humans, earthlings, late-night tea drinkers and stargazers, are currently at about 0.73. That's right. On a scale from planetary demigod to galactic symphony, we are still in the warm-up act. But don't be discouraged. That decimal is not a failure. It's a reminder. We are still in motion. Right now, we harness a tiny fraction of the sun's power, just what reaches Earth's surface. Most of it streams past us, unnoticed, untapped. We build dams, drill for oil, gather wind, split atoms, but it's fragmented, messy, often inefficient. Our energy systems are still primitive, brilliant, but primitive, and yet they work. Your phone charges, your oven bakes, your cat warms herself beside a heater. Magic, by any other name, and slowly we're learning. Not just to generate energy, but to understand it. Because if the Kardashev Scale teaches us anything, it's that how we use energy matters as much as how much we use. Let's linger here for a moment on this strange idea that a civilization could wrap a star in technology. The Dyson sphere, named after physicist Freeman Dyson, no relation to the vacuum cleaner, is a thought experiment, an answer to the question, if we wanted all of our sun's energy, how would we get it? The simplest version is a solid shell around the sun, but that's wildly unrealistic. The forces involved would tear it apart. More feasible models imagine Dyson swarms, thousands or millions of solar collectors orbiting the star, each gathering a slice of light, like petals around a flame. It sounds impossible, absurd, and yet, if you showed a smartphone to someone from the 1300s, they'd say the same thing. If you described GPS to a sailor from the 18th century, they'd laugh or pray. Progress is always impossible until it isn't. And here's the curious thing. Building a Dyson swarm wouldn't require breaking the laws of physics, just bending them, cleverly, patiently, at scale, because scale is everything. A Dyson swarm wouldn't be built in a day or even a century. It would grow, slowly, module by module, robot by robot, until one day the sun would shine a little dimmer from the outside and a little brighter from within. That's the leap from type 1 to type 2, from planetary to stellar, from earthbound to sunbound. But let's come back, gently, to where we are now. Our current global energy consumption is roughly 18 terawatts. That's 18 trillion watts, a staggering number. Enough to boil oceans if used unwisely. Enough to run billions of light bulbs if used well. Yet compared to the sun, it's nothing. The sun bathes Earth in about 174,000 terawatts every second. That's more than 10,000 times what we currently use, and that's just what touches us. The full output of the sun, every blaze, every burst, every photon, is estimated at 400 yottawatts. That's a 4 followed by 26 zeros. We can't even imagine it, but it's there, raining down, slipping past us, untouched. The Kardashev Scale is not just a way to measure growth, it's a mirror for humility, and yet, hope. Because we're not empty-handed. We've built solar panels that sip from starlight. We've developed fusion experiments that try to mimic suns in bottles. We're building smarter grids, cleaner turbines, better batteries. We're learning. And the faster we learn, not just to create energy, but to coordinate it, the faster we climb. Because energy alone is not enough. To move up the scale, we must also master distribution. Imagine giving a caveman a power plant. Without understanding, it's just a pile of rocks. Understanding is key, and that's where the Kardashev Scale intersects with systems, with sociology, with strategy. It's not just about invention, it's about intention. A Type 1 civilization doesn't just have energy, it balances it, shares it, regulates it. It creates harmony, not just horsepower. And that might be the true message hidden in Kardashev's idea. Not, look how mighty a species can become, but look how coordinated it must be. That idea, quiet, persistent, might be more powerful than any reactor. Because something happens quietly when we begin to see energy not just as utility, but as identity. Not as a number on a spreadsheet, but as a reflection of who and what we are becoming. At its heart, the Kardashev Scale isn't really about technology. It's about consciousness, stretched outward, amplified, made radiant. You see, when a species starts manipulating power on a planetary scale, it also begins to rewrite its own nature, no longer shaped only by environment, but shaping the environment itself, no longer drifting through weather, but directing it, no longer surviving by chance, but thriving by design. A Type Siestwin civilization doesn't just capture Earth's energy, it becomes a steward of Earth. It manages climate, maintains balance, preserves ecosystems while extending its reach. It must, or it won't survive long enough to make it to Type 2, and that's the first great paradox of Kardashev's ladder. To grow vast, we must grow wise, because the higher the scale, the higher the stakes. We often imagine power as freedom, as the removal of limits. But energy, real energy, doesn't just liberate, it binds. The more we control, the more we're responsible for. A campfire warms a village, a fusion core powers a city, a star in your grasp. That's the weight of suns and consequences. So what does it look like? This shift from planetary survival to planetary symphony. Imagine weather forecasts that don't just predict storms, but diffuse them. Imagine deserts blooming not through miracle, but math. Imagine food grown in skyscrapers, energy pulled from the tides, and pollution turned into clean air, not by accident but by design. That's a world where energy isn't something we extract, but something we partner with. To reach that place, though, we'll have to confront something deeper than engineering. We'll have to confront our impulses, because for most of human history, energy has been something we've burned. Wood, coal, oil, gas. Even in our language, burnout, fiery passion, spark of genius. We equate power with consumption. We burn fuel, burn time, burn the candle at both ends. But fire is not a future. Fire is a beginning. The real leap, the one that takes us up the Kardashev Scale, happens when we stop burning and start building. When we stop measuring energy by how much we can take and start measuring it by how much we can sustain. Solar, wind, fusion. These aren't just technologies, they are philosophies, soft, persistent, generous, like the sun itself. Now let's imagine the next step, Type 2, and ask what that actually means for a species. To build a Dyson swarm, for example, would likely require automation at scale, self-replicating machines, swarms of intelligent probes mining asteroids, refining metals, assembling panels in the vacuum of space. It would take patience, hundreds of years, maybe thousands, not a burst of progress, but a slow blooming, like coral in the deep sea. And yet, we are already sowing the seeds. Space agencies are experimenting with solar sails. Private companies are building reusable rockets. Scientists are planning mining expeditions to near-Earth asteroids. There are serious peer-reviewed papers on megastructure design. And still, we haven't solved hunger. That's the contradiction. And the warning. Because climbing the Kardashev Scale isn't just about tools, it's about timing. If we chase stars before we fix Earth, we may bring our chaos with us. And yet, there's hope here too. Because energy isn't just external, it's biological, emotional, psychological. Inside you right now, a tiny organ called the mitochondrion is converting glucose into ATP, molecular energy. Every thought, every breath, every word you speak, powered by ancient chemical processes. Your body is a universe of reactions, tiny factories, soft dynamos. Life is energy, structured, cycled, sublime. Even your thoughts about the Kardashev Scale, this very moment of imagination, is a dance of electrochemical fire. Neurons firing, synapses lighting up, microscopic power surging through silence. You are, in every sense, powered, and so is everything else. The tree outside your window, it's a solar collector, one that stores sunlight as sugar and gives back oxygen in return. The ocean, a thermal battery soaking up heat, releasing it as storm or calm. The Earth, a spinning dynamo with a magnetic field strong enough to deflect solar wind. Nature doesn't need megastructures. It's been running an energy economy for billions of years. Zero waste, full return. So maybe, just maybe, the higher rungs of the Kardashev Scale don't look like gleaming metal rings around stars. Maybe they look like harmony. Maybe a truly advanced civilization doesn't dominate energy. It blends with it, dances with it, balances production and protection. Maybe Type 2 isn't louder, it's quieter. And Type 3, perhaps that's not conquest of galaxies, but understanding them, listening to them, becoming a part of them. Because if the universe is a machine, it's also a mystery. And power without perspective is a dangerous thing. Still, we dream, and rightly so. Because dreams too are powered, not by physics, but by possibility. And that's what the Kardashev Scale truly offers. A map, not of territory, but of becoming. A map that says, here's where we are, here's where we could go, and here's what we'd have to become to get there. To wield the energy of a planet, we must first learn to share it. To capture the light of a star, we must first learn to see it, not just as a fuel source, but as a miracle. To master a galaxy, perhaps we must first master humility, and that, in the end, is the strange beauty of this quiet cosmic scale. It measures watts, but it reveals values. It's not a scoreboard, it's a compass, pointing not just upward, but inward. And maybe, as we drift into sleep tonight, that's enough. Not to finish the climb, but to keep climbing, together. So far we've climbed gently through dreams and definitions. We've felt the glow of potential, the vastness of scale, the subtle shift from spark to sun. But now, let's wander into the machinery of it all. Because behind the poetry, the metaphors, the mirrors, the longing, there is something solid, humming beneath, the mechanics of energy. Not cold, not clinical, just beautifully precise. Let's begin with the basics. What would it actually take to move from where we are, a Type 0 point-something civilization, to that first bright milestone, Type 1, a planetary civilization? To reach this level, we would need to capture, store and manage roughly 10^16 watts of power. That's 10 quadrillion watts, 1,000 times more than what humanity consumes today. To put that in perspective, imagine lighting up every light bulb, every street lamp, every screen, every device across the entire Earth, and then multiplying that by 1,000. Imagine powering cities under oceans, deserts that bloom because we will them to, satellites that orbit not just for signal, but for balance, redistributing solar energy between hemispheres like celestial thermostats. The tools for this don't belong to the far future. They're already beginning to arrive, piece by quiet piece. Solar power, of course, sits at the centre. Every second, the Earth receives enough sunlight to power all human activity for over an hour. Yet we collect only a sliver. Our solar panels are growing smarter, thinner, more flexible. Some are transparent, built into windows, rooftops, even paint. We are learning to harvest light, not with force, but with finesse. Then there's wind, ancient, patient, ever-present. Wind turbines have gone from creaking rural oddities to vast white sentinels turning over hills, coastlines, and even seas. The largest ones now rival skyscrapers. Their blades sweep through football fields of air. One rotation can power a home for a day, but wind is not just power, it's rhythm. And then there is geothermal, heat from below, the molten whisper of Earth's core, still largely untapped, yet as constant as breath. In Iceland, entire towns run on this invisible fire. Elsewhere, it bubbles underfoot, waiting, silent, ready. These aren't distant dreams, they're gatherings, small steps toward planetary stewardship. And yet, even if we captured every sunbeam, every breeze, every molten pulse, we'd still need something more: storage. Because energy isn't always where or when we need it. The sun doesn't shine at night. The wind doesn't blow on command. Geothermal heat lies deep behind walls of stone. So we build batteries, not just in phones or cars, but in grids, massive humming vaults of stored possibility. Some use lithium, others gravity or salt or even liquid air. There are batteries that lift concrete blocks during the day, then lower them at night, turning potential energy into power. There are underground caverns where compressed air waits like breath held in lungs, released only when demand rises. Storage is the unsung hero of energy progress, the quiet in between that makes continuity possible. And all of it, generation, transmission, storage, must be coordinated. This is the heart of the next phase, because to be a Type 1 civilization isn't just to have more power, it's to have conscious power, every watt accounted for, every surge absorbed, every need anticipated. Think of a planetary nervous system, sensors embedded in forests, oceans, cities, satellites monitoring cloud cover, lightning strikes, glacier melt, smart grids shifting power minute by minute, not just reacting, but predicting. In this world, an approaching heatwave triggers cooling before it hits. A distant thunderstorm reroutes energy away from danger. A volcano's early tremor sends alerts to stabilize supplies and shield infrastructure. This is resilience made real, not through fear but foresight. And beyond the Earth, the next rung, Type 2. A civilization that no longer leans only on its planet but reaches into space itself and begins to build there. We touched on the Dyson swarm before. that dream of millions of mirrors, panels, and collectors orbiting the sun. But let's look closer. To build a Dyson swarm, we'd likely start small. Robotic factories launched into orbit, mining drones sent to asteroids, extracting metals, regolith, water. Each drone builds more drones. Each panel builds more panels. A chain reaction, not of destruction, but creation. Eventually a cloud begins to form, not of smoke, but of structure. A sphere, not solid, but alive. Orbiting, updating, evolving. This would be humanity's first true exoskeleton. A machine that lives outside the body but works in service of it. But here's a thought. Would that swarm still be ours? At that scale, millions of independent machines guided by artificial intelligence building and repairing themselves, how much human oversight would remain? Would we be conductors? Or just the composers long since retired? That's the mystery. Because as our systems grow more complex, our direct control begins to fade. We don't manage every electron in a circuit. We don't tell every water molecule where to flow. We design patterns. We set rules. And then we let go. And that too is part of growing. To become Type 2 is to decentralize, to become more like a forest, more like weather, more like nature, complex, adaptive, and quietly self-sustaining. Of course, that brings challenges, ethical, philosophical, existential. Would we be creators or caretakers? What if the swarm decided to evolve beyond our intentions? What if we needed the energy, but no longer understood how to retrieve it? And yet, those questions too are part of the journey. No civilization climbs the Kardashev Scale without confronting the limits of its own ego, because the higher you rise, the more you must release. Let go of dominance, embrace collaboration, accept that control is an illusion, but coordination is everything. This is where technology begins to look less like machines and more like ecology. Swarming bots that mimic bees, satellites that adjust their orbits like birds on wind, AI that doesn't just calculate but learns, adapts, even dreams. So here we are, still Type 0 point something, but surrounded by signals of ascent. Solar panels in fields that once grew only corn, electric buses whispering through city streets, skyscrapers that breathe, adjusting their windows like gills, homes with roofs that think. We are not yet a planetary civilization, but we are becoming one, quietly, softly, system by system, choice by choice. And perhaps the most important piece isn't energy at all, it's awareness. Because awareness of our limits, our impact, our potential, is the switch we must flip before any others will truly matter. We've climbed carefully through watts and wind, sun and systems. We've peered at Dyson swarms orbiting in the imagined near future, and seen how becoming powerful might first mean becoming balanced. But what happens when we move past balance and into mystery? What happens at the edges of the Kardashev Scale, in the places where theory blurs into thought experiment and reality tiptoes toward wonder? Let's start with an odd idea, one whispered by scientists and science fiction authors alike. What if we've already seen Kardashev Type 2 or 3 civilizations and didn't know it? Because here's the thing, advanced energy use doesn't necessarily glow brighter. Sometimes it dims. A civilization that envelops its star in collectors, a full Dyson swarm, would block visible light. From a distance, that star would no longer shine as it once did. It might appear to be cooling, fading, even dying. But in the infrared spectrum it would glow. All that captured energy must go somewhere. Even the most efficient machines produce waste heat. That heat would radiate outward, a different signature, detectable not with telescopes tuned to starlight, but with those attuned to thermal breath. Astronomers have looked for these signs, searches through catalogues of stars, surveys of galaxies, hunting for strange dips